All right, let's do this. So welcome to homework this week. Let's talk about arrays. So as we talked in class, arrays are a collection of the same data type. Over here you'll see this is one data type. It looks like integers. It starts at index location 0. Even though the length is 10, the last index is 9. And each index has an element. So this is an array of integers. 10 of them. It can have negative numbers, it could have 0, any, as long as it's an integer value, it can hold it. Okay, so this is kind of how it looks like. If this is called data, it's saying data at spot 0, so that's saying the index contains the value of 23. Data at index 5 has the value of 14. Okay, so if there are n cells, the indexes will be 0 through n minus 1. Index, you could also use the word subscript. They like to use that on the AP test. The values are also known as elements. Okay, so here we're going to be talking about using arrays. Okay, if your original data had -3 stored at the index of 3, I could say data at index 3 is now equal to 99. So what I've done, nothing besides index 3 changed. So that's how before I called this line of code and after, just like you would do a variable. Okay? Arithmetic operations, same as a variable as well. Okay? So here I said data 0. It was 23. I said it's equal to whatever x is, if x contains 10, plus whatever spot 2 is, divided by 4. So you can use the actual index. This returns the element value. So data at index 2 returns 14. So this would be 10 plus 14 divided by 4. Which would equal 6. So then spot 0 would now equal 6. Okay. So the difference between arrays and variables, particularly variables like int. Int are primitive values where arrays are objects. So the other arrays we've used before are strings. So an array has one data type, and when you have to give it a name just like a variable, and when you do create an array, you also have to say, let's make this a little smaller, you also have to say what data type followed by these brackets that says it's an array, the array name, and the new, because it's an object, what data type again, so same as here, and then arrays, the important thing here is that they do not change in size. So you have to give it an initial size for when you initially create your array. Okay, so in the array, there's different methods, and dot length allows you to see how large it is, and you want to use that because if you go out of bounds, it would crash. So you just want to make sure you are testing for that. So here, it shows a couple examples. If you've got, this is an example of creating an array that's 10 integers long. You can't try to do any negative number in an array because no such position exists. If you go too far, if I try to find what's at spot 10, remember it's 0 to 9, so that would be illegal as well. Indexes are always integer values, so you couldn't find what is at index 1.5 because that crashes. You can find out what's at spot 0 or what's, as long as the array is that size. And here it shows if j was a number between 0 and 9, that would work as well. Okay. All right, so we already talked about how you make an array, but here's a further example. Okay, here's an integer array that stores 5 numbers. Okay, so here I've said spot 0, spot 1, and spot 2 equal these numbers. Okay, then if I went ahead and print these numbers, it would say stuff 0 has 23. And then it would say stuff 1 has 38. Stuff 2 has 14. Stuff 3, because I didn't give it an initial value, it will give me 0 because it initially gives an initial value as 0. It is different than a variable where if I just said int stuff semicolon and then I tried to print what stuff was, it would crash. But here it gives initial values. Okay. So here we're talking about using a variable as an index. Okay. So here's us creating a integer array. We've said spot 6 is equal to number 42. Our index as a variable is equal to 0. I can say the value at index is equal to 71. You use this a lot when you use loops, when you're looping through an array to find smallest, largest, sorting, or just searching through every item in your array. Okay. All right, so here, once again, this is just saying spot 0, spot 1, spot 2. Here you can, just like using substring, you can say call an array at a location minus some number. As long as you're not out of bounds, everything works. Okay. Moving on. Here, this is a second way of creating an array. So also it is called a list here, and there's something called array list that we're not going to talk about yet. But arrays and array list both fall under this category list. So the second way of creating an array is to say, you have to say what data type it is, what name it is, but now I'm giving it initial values at each specific location. And so by default it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's like saying int data equals new int 10, and then spot 0 equals 23, 1 equals 38, and so on. So this is the second way of creating it, and it gives it all initial values. So now in order for you to copy values from one array to another array, okay, here I am copying. An assignment operator works as what's on the right gets sent to the left. Okay, so I'm saying value B, store what's at value A at spot 0. Okay, so this is very different than what's up here. Okay, here I am giving specific values, and they're primitive values. If I said array B equals array A, you're actually saying value B point to the memory location of where value A is as well. So now you're just basically giving value A a second nickname. So value A now is also called value B. So if you change value A, value B changes as well. So there's not many times you want to do this. So when in doubt, don't use an equal sign when you are trying to copy an array from one array to another array. Okay, so this works with all objects. Okay, because each object, if I were to print off value A, it would actually print the memory location. So that's what value A stores as a memory location. So that's how this equal sign works, is value B equals the memory location of value A. Therefore, they both equal the same memory location. Okay, so that's pretty much it with the array. there's a couple things that they're talking about here. Counting loops, enhanced for loops, and the length of the array. So here you've created an array. This is creating a loop that goes through 10 times. Now later we're going to say, well, index is less than the example array dot length, but for now it starts off easy. Okay, and here it shows printing off this index at the array. Okay, so here it's printing every location. Index starts at 0, ends at 9 of your array. Okay, now we're going to be using the length of array a lot. So here it shows printing, instead of going up to spot 10, use the dot length. Now, one thing to notice is it doesn't have parentheses after length. String has parentheses after length, but arrays do not. The reason is length is actually an instance variable of the array. It is not a method, because when you create an array, you also have to give the size of it. That is the instance variable of that array. So that's the difference between using dot length of a string and using dot length of an array. So when you read each element, this is just making sure you use a for loop that goes in bounds, okay? And you are printing off the array at every index, and that's nice and easy. Okay, moving on is you've got, if you want to find the maximum or minimum of an array, is just like we've done before. You need a variable that stores either the max or the min. Now the one thing you don't want to say is max equals 0, because if all these numbers were negative numbers, your max would store the value of 0. Instead, you want to store what is at spot 0, because now the maximum is negative 20 in this example, instead of having it originally being 0. So now you can compare. Here you don't have to start at spot 0, because you could even start at spot 1, because you've already have spot 0 as your max. Okay, so here it is. They want you to use spot 0. Okay, and here, if the array at spot index is greater than your max stores what is at that location that is bigger than your max. Okay, so that's pretty much it for finding your biggest or smallest. This is called an enhanced for loop. An enhanced for loop is, traditionally we've had to make an array, a for loop that starts at 0, goes to the length of it, and increment that variable by 1. Instead, our for loop looks like this. We're saying for whatever data type the array is. See, my array is an integer array. I've said integer. I give each value in my array a variable name, and then what array I'm going through. Array is the name of the array, so that is the name I am giving it here. Now the difference between a regular for loop and an enhanced for loop is a regular for loop stores the index location. An enhanced for loop stores the elements. So here, in an enhanced for loop, I can just say if value is greater than the max. Whereas back in the regular for loop, here's the regular for loop. See, it goes 0 to the length of the size. I had to use the array at an index location, where this for loop is going through every index. Okay, so the enhanced for loop is nice because it's less code up here and it's less code here. Now you use enhanced for loops, well, you never have to use it, but they're beneficial when you have to test every item